This route finder returns a cost of 8. But the best route on the same map costs 7. Nothing is hidden. Both routes share the same junction. So how did the algorithm walk past the better path? The culprit is a greedy-looking choice inside A star, combined with one rule about nodes that have already been closed. Here is the whole example. Start at S. The goal is G. From S, both A and B cost 2. A reaches the shared junction C with one more step. B reaches C with 2. From C to G costs 4. A star ranks a frontier node with F equals G plus H. G is the cost already paid, and H is a lower bound estimate of the cost still to come. The estimates are S6, A5, B2, C1, and G0. Every one is optimistic. None overstates the true remaining cost. After expanding S, A has G2 and F7. B also has G2, but its estimate is only 2, so B's F is 4. The priority queue pops B first. That is the greedy-looking moment. B appears closer to the goal, even though the route through A has not been disproved. B reaches C with G equal to 4. C's F is 5, so it is popped next and moved to the closed set. From C, the algorithm creates a goal route with cost 8. There is still an unexpanded A in the queue with F7, but C now looks like a finished fact. The implementation has made a quiet assumption. The first path to a closed node must be its cheapest path. Now, A is finally expanded. Its edge to C costs 1, so A reveals a route to C with G equal to 3, 1 cheaper than the 4 we recorded. But C is already closed. The no reopen graph search rule refuses the improvement. The queue then pops the 8 cost goal. The algorithm did not fail to see the better edge. It failed to let that edge change a decision it had already frozen. Why was that freeze unsafe? A star needs more than an optimistic estimate when closed nodes are treated as final. A consistent heuristic must obey this local triangle inequality. H of a node is at most the edge cost plus H of its neighbor. On edge A to C, our value, say 5, is at most 1 plus 1. That is false. The estimate can jump downward along a path, so F is not guaranteed to rise. A cheaper route to a closed node can still appear later. The repair is small. When a cheaper G value appears, reopen that closed node instead of discarding it. C changes from G4 to G3. Its goal entry is updated from 8 to 7, and the returned route is S, A, C, G. The priority queue was still useful. The mistake was treating its old closed set as permanent under an inconsistent heuristic. So the practical rule is conditional. If your heuristic is consistent, the usual no-reopen graph search is safe. If it is merely admissible, test for a cheaper path to every closed node and reopen on a strict improvement. Keep this 5-edge graph as a regression test. The broken version must return 8, and the repaired version must return 7. Greedy choices are not automatically bad. The danger is freezing a choice before your heuristic has earned that trust.